Hi, this is Mr. Steinerson. In this video, I'm going to build on the things you've learned already about naming with ionic and covalent compounds and writing formulas to combine them into one, which is a mixed naming exercise. So we'll learn how to decipher what naming rules to apply and when. First, I'd like to review a few basics that we've learned already in previous skills. We've talked about types of bonds, both ionic and covalent, where ionic bonds happen between a metal and a nonmetal. They use charge to determine the number of atoms, therefore the subscripts in a compound. So if I take a look at magnesium phosphate, for example, I know that magnesium has a +2 charge, phosphate has a -3 charge. Therefore, when I combine them together to make a neutral compound, I need 3 magnesiums and 2 phosphates. Similar things happen with potassium bromide, aluminum oxide, and copper 1 oxide. These types of things are all part of ionic bonding. Now I mentioned a Roman numeral, and that is the last part. When we talk about multivalent metals like copper and iron, we need to include a Roman numeral in the name. Okay, so that covers ionic. When we skip over to covalent, we know that a covalent compound happens between a nonmetal and a nonmetal in the periodic table. We will use prefixes to determine the number of subscripts instead of charge. So when I take a look at compounds like silicon dioxide, SiO2, or carbon tetrachloride, CCl4, I'm using the prefix in the name to help me determine the subscript. So let's give this a try. Say we have a compound, MnPO4 2, and we need to name this. We're going to use the criteria at the bottom to help us walk through some of the steps. The first thing to do is to identify if this is ionic or covalent. The way we're going to do that is looking at the first element, in this case manganese, we're going to decide if it's a metal or a nonmetal. Since this is on the metal side of the periodic table, I know I'm dealing with a metal. And once it's a metal, that means that the compound, if it's a metal first, is going to be ionic. So I can write down the name of the metal, in this case manganese, and then look to see if it is a metal that has more than one charge. In this case, it is. Looking at the periodic table again, I notice that manganese can have multiple charges. In other words, it's multivalent. So I'm going to need to use the negative charge to help me determine what charge manganese is using. In this case, I'm going to look to my polyatomic ion, phosphate. And I know that phosphate has a -3 charge, but in this case there's 2 of them. So my total negative charge is -6. For this to be a compound, charges have to add to 0. So I know I need to have a +6 charge. Since there's only one manganese, all +6 charge is going to be included in that one element. So then I can go and add my Roman numerals. So I'm going to put in parentheses a Roman numeral 6, or Vi, to show that it is indeed using its +6 charge. Now I can finish by writing down the name of the polyatomic ion, in this case phosphate. I know it's going to be phosphate because it's PO4. So to quickly recap, we identified that the metal came first, making it an ionic compound. We knew the metal was multivalent, so we used the charge on the phosphate ion to help determine what charge the multivalent metal was using in this compound, in this case a +6, and wrote that as a Roman numeral. So therefore the full name is manganese 6 phosphate. Great job on the last one. Let's give this next one a try. We're going to write the name for N2O3. Once again, I'm going to check on the periodic table to find nitrogen. And in this case, nitrogen is on the nonmetal side of the periodic table. Because nitrogen is a nonmetal, that is a big clue that we're dealing with a covalent compound. To name a covalent compound, we'll write the name of the element using prefixes. So when you look at the common prefixes, like mono, di, tri, tetra, penta, all the way to deca for 10, we're going to use that to write down how many atoms there are in this compound. In this case, we're dealing with 2 nitrogens. So I'm going to use the prefix di to stand for 2. And it'll look something like this. We'll have dinitrogen, and notice I'm not changing the ending of nitrogen, I'm keeping it as is. So dinitrogen, and now I'm going to look to see how many oxygens there are. Notice there are 3. So I'll use the prefix for 3, which is tri. So I'll write that as tri. And in this case, I do change the ending to IDE. So this would be trioxide for its full name for this covalent compound. Nice work. Of course, the true test comes when we're mixing ionic and covalent, multivalent, and polyatomic, binary all together. So let's take a look at this next example. Say we have Cu3P and we need to name this. I'm going to first have to identify as the first element a metal or a nonmetal. That's right, in this case it's a metal. So I know I'm dealing with an ionic compound. So I can start by listing out the metal's name. In this case it's copper. What I need to do though is identify, is that copper multivalent? And looking at the periodic table, I see that it is. It has a possible charge of a 2 or a 1. So I'm going to need to use the charge of the other atom to help me figure this out. So looking at the periodic table, I also know that phosphorus is going to come with a -3 charge. To balance a -3, I have 3 atoms. Each one must have a +1 charge. So in this case, I know that copper is using its 1 or +1 charge. So I'll write a Roman numeral 1 and then the ending. We're going to change phosphorus to phosphide. The IDE ending indicates a binary compound. Alright, let's take a look at the next one. We're still dealing with copper, but what's different? Hopefully you've noticed that this is not just phosphorus, but a polyatomic ion, phosphate. And take a look at the amount of atoms. We have 3 atoms of copper that balance this. Once again, we'll look to the charge. Phosphate, just like phosphorus, has a -3 charge. Each copper must then have a +1 since there are 3 of them. We're going to translate this to a Roman numeral as we write out the formula name with copper, Roman numeral 1, and now this would be phosphate. Notice the ending changed from "ide" to "ate", and this is true because we have now a polyatomic ion instead of just a binary compound. Still held together with a charge, but now we're dealing with polyatomics instead. Give the last one a try. Hopefully for this last one, you've noticed some similarities. We are again using charge. We have a -3 charge for phosphate. We know we're dealing with copper as the metal, but copper may have a different charge in this compound. To make sure, we're going to look at the negative charges. Right now, I have 2 -3s, so that becomes a total of -6. On this side, I need a +6, but it's divided between 3 atoms. So each one would have to have a +2 charge. I'll take that +2 and write it as a Roman numeral in the name. So it becomes copper 2. Once again, we're dealing with a polyatomic, so copper 2 phosphate is the official name for this compound. Nice job. Let's take a look at the last one. We have C and Cl4. Looking at the periodic table, carbon is considered a non-metal. So therefore I'm going to be using my covalent naming with prefixes. So this one becomes carbon, tetra, because there are 4, chloride. A big thing to remember is even though there's only one carbon in this case, we do not use mono in the first term. That's only reserved if there was one in the second. Okay, at this point you're probably asking yourself, how am I going to keep this all straight? Well, one tip is to look at the ending of the names. If you see an "ide," "ate," or "ite" ending, it can help you determine if you're dealing with a binary or polyatomic ion. And that can help you then figure out the formulas. So, for example, if I'm looking at magnesium nitride, the IDE ending tells me it's binary. And so I'm just dealing with magnesium and nitrogen. So I know it's Mg and N. Now it's just a matter of figuring out the subscripts. Nitrogen has a -3 charge, and magnesium has a +2 charge, so therefore I need to balance these out by having 3 magnesiums and 2 nitrogens. So it'd be Mg3 and N2. Okay? I can do the same thing when I get down into nitrate and nitrite. Notice the difference in the ending, ATE and ITE. That's a clue that we're dealing with a polyatomic ion. In this case, the polyatomic ion nitrate is NO2, 3, and the polyatomic ion nitrite is NO2. So filling in with magnesium as the metal, we're just going to now fill in our charges. Nitrate is a -1 charge, magnesium is a +2. Nitrite is also a -1, with magnesium being a +2. So now when I look at balancing this out, I need another group of nitrate. Please use parentheses to keep the groups together and put the subscript outside. So this would become Mg parentheses NO3 N2, showing that there are 2 groups of nitrate. Same thing with nitrite. I'm going to need 2 groups of nitrite in order to balance this out. Nice work. Okay, we've got the basics down. At this point in the video, I want to talk about a couple exceptions and some common mistakes. A few exceptions to the IDE ending show up with polyatomic ions. For example, hydroxide has an IDE ending, but it is a polyatomic ion. Sorry, you just got to memorize that. Also, ammonium doesn't have an ate or an ite ending. It is just ammonium, and you'll have to memorize that that's also polyatomic, NH4 with a +1. Alright, now let's talk about a few common misconceptions. One of the most common mistakes when first learning how to do naming and writing compounds is confusing when it's a polyatomic ion or when it's a compound. The first example is actually a compound, and the way I know is there's no charge. Where SO3 -2 or 2-, that's a polyatomic ion. And I'm going to treat them very differently. The SO3 is going to be called sulfur, and since it's a covalent compound, a nonmetal first, nonmetal, nonmetal, I'm going to use prefixes, so this would be trioxide. However, if I see that it is a polyatomic ion with a charge, the polyatomic ion in this case is sulfite. Okay? Notice the difference. We're talking about a compound here and a polyatomic ion here. Easy to confuse, but just look for that charge. Another common mistake is when you name them in the compounds. Okay? For example, this compound has potassium and this sulfite. Be careful that you use potassium and then the name of the polyatomic ion, sulfite, in the name. This should not be called dipotassium monosulfur trioxide. That's really wrong. Please don't confuse the prefixes when you're dealing with ionic compounds. All right, one more misconception and then you're on your way. Okay, for our last misconception, I'm going to have you figure out what's wrong. If I have a compound name of calcium chloride and I've written a formula over here, this formula is not correct. Pause the video for a second and see if you can figure out what's wrong. All right, nice job. You notice that chlorite is a polyatomic ion, and it is ClO2. However, when we look at the charges, calcium is a +2 charge, and chlorite is a -1. I'm going to need 2 chlorites. The common mistake here is when you write out chlorite that you just put a 2 next to the oxygen. This only indicates that it's chlorite. To indicate there's 2 of them, you need to include parentheses and put a 2 outside the parentheses. Now I'm showing that there are 2 groups of that chlorite ion. Hopefully that makes sense. The other misconception is on the bottom. See if you can figure out what's wrong. Pause the video for a second. Yep, you got it. Somebody used prefixes when there was a metal first. This just becomes potassium oxide. There's no need to use prefixes for ionic naming, only in covalent. Well, that about does it for this quick tutorial on mixed naming. Please take a look at your practice problems and your Schoology quiz check for this, and let us know if there are any questions you have during class. Thanks a lot, and have a good day.